In this video, we will practice graphing sine and cosine as we change the amplitude and the period. The phase shift won't actually be changing during this video. First, some quick background information. Your basic sine function, y equals sine x. It goes like this. Your basic sine function has a period of 2 pi. All right, that means one repetition. It has an amplitude of 1, meaning it goes up to 1 and down to -1. So here in the middle would be pi, and this would be pi over 2, and this would be 3 pi over 2. So your basic sine function starts at 0, and then it goes up, and then back to the midline, and then it goes down to its minimum, and then back to the midline. So this is what your basic sine function looks like, and you should memorize that. Contrast that with your basic cosine function. All right, it also has a period of 2 pi, so the critical values will occur at pi and pi over 2 and 3 pi over 2, just like it did for the sine function. All right, so we're talking about cosine, y equals cosine x. Cosine also has an amplitude of 1, so it should go up to 1 and down to -1. Unlike the sine function, you know what, I think I'll do this one in blue. Cosine function starts off way up high at +1, and then it goes down to the midline, and then it goes down to its low, and then back to the midline, and then up to its high. So this is what the parent function for cosine should look like. So basically memorize that. Now, a couple other things. When we talk about the general form of a periodic function like sine, it goes like this: y equals a, and then we have the sine, and then inside of here we have b, and then we have x minus h, and then on the end we have plus k. This a in the front tells us the amplitude. All right, that's how high and low the function goes. So, for example, if this was a 2, then the graph would go up as high as 2, and it would go down to a low of -2. So it might look something like this if it was a sine function. Amplitude is always positive. Now, the b value, I feel like I should switch colors. The b value helps you figure out what the period is. Like on the basic functions I did so far, the period was 2 pi. But that will change if you have a b value. And the way you can find the period is that the period is always going to be 2 pi divided by that b value. Now, in this video, we're not going to deal with the h and k, but I'll just mention them briefly. The h and k will be horizontal and vertical translations. So this h is a horizontal translation, and that's called a phase shift when you're dealing with a periodic function. We'll deal with that on another video. And this is a vertical translation, which we will deal with on another video. So for now, I want you to focus on the amplitude, which is going to come from the a, and the period, which is going to be affected by this b value. And again, you can find the period by doing 2 pi divided by b. So that should be enough to get us started. Okay, so the amplitude is going to come from the a value, which is here in the front. So for this problem, the amplitude is 4. The period would come from the b value, but this problem does not have a visible b value, or you could say that the b value is 1. Either way, that means the period is going to be unchanged from the usual 2 pi. There is no phase shift because there is no h or k value. There's nothing being added or subtracted. So there is no phase shift for any of these problems that we're going to be doing in this video. So for phase shift, we can just say none. And that is enough information for us to sketch this graph. So here we go. Since the amplitude is 4, we're going to allow our graph to go up to a high of 4 and a low of -4. Since the period is 2 pi, over here we'll just go ahead and call this 2 pi. So of course halfway will be pi, and then right here will be pi over 2, and this will be 3 pi over 2. Now we are dealing with the sine function, and the sine function always starts off at 0, and then unless it's reflected over the x-axis, it will go up and then down and then back. So it should go up to the maximum value and then back to the midline and then down to the lowest value and then back to the midline. So this is what one period of this function should look like. So that's it for problem number 1. Now for problem number 2, the amplitude is affected by the a value. There's no visible a value, which means that the a value is a 1. So that means the amplitude is simply 1. Now the period is affected by the b value. All right? This number right here is the b value. So remember that the period is going to be 2 pi divided by that b value. So in this case, the period is going to be 2 pi divided by 4, which means that the period, all right, 2 goes into 4 twice, so this is going to reduce down to pi over 2. So the period is going to be pi over 2. Again, there is no phase shift because nothing is being added or subtracted. So this should be enough information for us to draw the sketch. Okay, so here we go. Because the amplitude is 1, we will just allow the graph to go up to +1 and down to -1. Since the period is pi over 2, let's go ahead and call this pi over 2 all the way over here to the right. Now, half of pi over 2 should be pi over 4. Half of pi over 4 should be pi over 8. And what about this one right here? Well, I always like to look at this small one. So this is sort of like 1 pi over 8. And then this next one is like having 2 pi over 8. And this next one will be like having 3 pi over 8. Of course, 2 pi over 8 reduces down to pi over 4. The next one, if I kept going, would be 4 pi over 8. And notice that that does reduce back down to pi over 2. But it's useful to get this one in the middle. So just take your smallest unit and count with it. 1 of these, 2 of these, 3 of those, 4 of those. It really helps to find this one. So 3 pi over 8. All right, this labeling is important. You're going to be partially graded on having this labeled correctly. This is a sine function, so again it's going to start from 0 every single time. So there's no reflection over the x-axis. By the way, I keep mentioning that. If the a is negative, and I'll just go ahead and say If you see a negative sign sitting here in front of the a value, or you could just say if the a value is negative, this negative sign means it's going to be a reflection over the x-axis. Meaning it would be upside down. So looking at this picture, instead of going up and then down, instead it would go down and then up. All right, that's what it would look like if there was a minus sign. Anyway, this doesn't have that, so I don't have to worry about that. So I start at 0, and so then it should go up to its maximum, back to the midline, down to its minimum, and back to the midline. So this is what the one period of this sine function should look like. And notice it looks identical to the one we just did. What's changing is the scale. So you'll see that very often, that the graph will look the same, but what's changing is it's really only going up to 1 and down to -1 instead of, for example, 4 and -4. And instead of going to 2 pi like it did before, really this is pi over 2, even though it looks the same. Let's go ahead and look at number 3. The amplitude is going to be derived from this number right here in the front. The amplitude is 1/4. The amplitude is always positive, keep that in mind. Now the period is affected by the b value, which would normally be right here, right? Because this is the a value, and this is the b value. But there's no b value visible. That means b is 1. So the period should be just a regular old 2 pi. Now the phase shift will be none, because nothing is being added or subtracted. So now we should be able to draw the sketch. Okay, the amplitude is 1/4. So I could just say, well, let's call this 1/4, and let's call this -1/4. All right, that makes it easy. And way over here, we will put 2 pi, because of the period is 2 pi. So I'll put that down. Halfway in the middle should be pi. Half of that should be pi over 2. And then between these should be 3 pi over 2. This is still the sine function, so it's going to start from 0. And it's going to go up to its high, and then back to the midline. And then down to its low, and then back to the midline. So once again, the sine function is going to look like this. And the only thing that really changed is the way we labeled the axes. All right, let's take a look at number 4. All right, the amplitude is affected by the a value. But since there is no visible a value, that means the amplitude is 1. The period is affected by this b value. And the period is always 2 pi divided by that b value. So that means the period is going to be 2 pi divided by 1/4. All right, so when you divide by a fraction, that's the same thing as multiplying by the reciprocal. So 2 pi divided by 1/4 is the same thing as 2 pi times 4. All right, you multiply by the reciprocal. So that means the period is going to be 8 pi. And there is no phase shift because nothing is being added or subtracted. So for phase shift, we will just say none again. So that should be enough information for us to draw the sketch. The amplitude is 1, so that means it'll just go up to +1 and down to -1. The period is 8 pi. So all the way over here, I'm going to put 8 pi. Now, halfway in the middle should be 4 pi. And then half of that should be 2 pi. So this is 2, 4, 6. So this should be 6 pi right here. Now this is the sine function, so it should start at 0, and then it should go up to its maximum, back to the midline, down to its minimum, and back to the midline. So the graph for problem number 4 should look like this. All right, how about number 5? The amplitude is going to come from the A value. So the amplitude is going to be 2. Amplitude is always positive. The period is going to come from this B value. The period is always 2 pi divided by the B value. So the period is going to be 2 pi divided by 1/4. So 2 pi divided by 1/4 is the same thing as 2 pi times 4. You multiply by the reciprocal. So the period is 8 pi, just like on the last problem. So the period is going to be 8 pi. There is no phase shift because nothing is being added or subtracted on the end. So we will just put none. All right, now we should be ready to draw the sketch. Easy peasy lemon squeezy. Since amplitude is 2, that means it's going to go up to 2 and down to -2. Since the period is 8 pi, this will be 8 pi. Halfway will be 4 pi. Half of that will be 2 pi. 2, 4, 6. So this will be 6 pi. This is the sine function, so it should start at 0, and then it should go up to its maximum value, back to the midline, down to its minimum value, and then back to the midline. So this is what the graph for problem number 5 should look like.